Welcome back to the Lowdown on Physics. This is screencast number 3 for Unit 1 Physics Basic Electrical Circuits. Today we'll be looking at rules for current and voltage in series and parallel circuits. So before we get going, just want to have a look at something that we call a circuit descriptor. Basically it's something that just makes it really easy for us to, I guess for convenience, label everything so that we know what we're talking about on a circuit diagram. So what we use are little subscripts. So current through resistors, loads, various points around the circuit, we just label as I1, I2, I3, I4 and identify them on the circuit diagram. Same deal for voltage. Different voltages we would have a V1, a V2. It just helps us distinguish between the different ones and then we can talk about them without getting confused. So the basic arrangement for circuits, we use a descriptive name based on how the components are connected together. In a series circuit, there's only one pathway. All the current can only ever travel along one pathway to get there. Basically, the result of that is that the current must be the same at every point around the resistor. This is because whatever current's flowing through the power supply must pass through each of the loads along the way. So IPS there, the subscript is for power supply. So if we look here at this diagram, you've got your current from the power supply, conventional current from the positive to the negative terminal, which will then pass around, so the same current I1, same current as I2, same current as I3, and in this case you continue on to I4. So a really quick example. You couldn't ask for a better example or better test question. You know, you've got a series circuit, we've got a resistor, got all this information about the resistors. You've got 2 amps flowing through the 8 ohm resistor. What's the current where it's passing through the 5 ohm resistor? Well, it's a series circuit, so it's going to be the same everywhere. So it's going to be 2 amps through there, 2 amps through the power supply. Now when we come to voltage, we've got to think of it in terms of that amount of energy that we've given to each coulomb of charge. So what's going to happen is that your charge is going to deposit some of that energy at each of the loads around the circuit. So as a result, whatever the voltage is at the power supply, the sum of the voltages across all those other loads is going to add to the power supply voltage. So here we've got, assuming there's 4 loads, if there's 3 resistances, we're obviously only going to have V1, V2, V3. Yeah, so if we look here, 4 resistors, EMF, you've got V1 there, some energy consumed here, some energy consumed here, some energy consumed there, some energy consumed there. So it will give energy at each of those points. The way it gives the energy off to each of these depends on the resistance. The higher the resistance, the more of that energy that will be consumed at that point. So it will sort of basically share that load on a ratio. You know, the greater the resistance, the more energy it's going to take for that electron to pass through. Therefore, more energy will be used there. So if we just have a quick look at an example. Where's my example? There it is. If we have a quick look at my example here, to determine the unknown voltage, we've got a power supply there of 12, 3 volts used there, 1 volt used there, 4 volts are used there. That's a total of 8 volts so far. That means that there will be 4 volts consumed at this resistor. So the other circuit arrangement that we could come across would be parallel circuits. This is where we get more than one pathway. And in this instance, the current can't flow through every wire. It's got to split up between the different wires. So here, as opposed to series circuits, we're going to split it up and all the individual components or the different pathways, the current in each pathway must add up to the current that passed through the power supply. So here, say we've got it's splitting up three ways. You've got your current from your power supply passing out. Then we've got current 1 up here, current 2 here, and current 3 down here. In this instance, you're going to end up with the greatest current where there's the least resistance. Where it's easiest to pass through, that's where the bulk of the current will flow, and the harder resistance would have less current flowing. Of course, if they're all of equal resistance, you would have an equal flow of current through each of the pathways. Now for voltage, when we have them in parallel, the voltage will be the same across each of the pathways. That's because when the current comes through here, the electrons moving through each of the pathways will have the same amount of energy to give off. So whatever the energy that these electrons start with here, if that's passed, if the electrons then split up through these pathways, they then pass that same, or you could have that same amount of potential difference at each of these loads. So there would be the same voltage here. It would not matter what the resistance was. So quick example, find the unknowns. If we've got 12 volts here, then V1, V2, V3, the voltage across each of those would also be 12 volts. 5 amps is coming in. That means if we jump over to I2, 5 amps has to come out. And if we look at I1, there's 2 amps have gone this path, 2 amps have gone that path. That means 1 amp of current has flowed through this path. So I1 is 1 amp. Interesting, we could note here that this resistance must be double what those resistances are there, because we've got half the current flowing through it. And that just brings us to one other thing that I want to touch on, and that's a junction rule. And basically what that says is the sum of the currents entering a junction must be the same as that exit. So we can, in this case of this example, represent it this way. So you've got I1 and I2 coming in, I3, I4, I5 going out. So those three there must add to the total of those two there. You know, pretty much whatever goes in has to come out. So the key points really today are for series, that the current must be equal. If we go to parallel, the current will break up into the sum of the parts. For voltage, it's the opposite. When it's in series, the sum of the parts will add to the power supply, and when they're in parallel, those voltages must be equal. If we can remember that, that will set you really up, really well for this topic, but also as a good foundation for Unit 3. Thanks guys, that's it. I'll see you in class.